Hi guys, welcome to my channel. In today's video, we are going to study syntax analysis and semantic analysis. The syntax analysis is the second phase of the compiler, where semantic analysis is the third phase of compiler. These phases ensures that the program is not only grammatically correct but also logically meaningful before it is translated into a machine code. Let us go into the slides and let us see in detail. The agenda of today's presentation: compiler phases, syntax analysis, parse tree, abstract syntax tree, parsing techniques, semantic analysis, symbol table, type checking, syntax versus semantic errors, and summary. We'll go into the slide. The position in compiler design. The source program given to the lexical analysis, where lexical analyzer first convert the source code into a tokens such as like keywords, identifiers, operators. These tokens are passed to the syntax analysis, where the compiler checks whether the program follows the grammar rules of the programming language. After successful passing of the program moves where the compiler verifies the meaning of the program by checking data types, variable, declaration, and scope rules. Finally, the program proceed to intermediate code and code optimization and code generation. So the syntax analysis checks the grammar, semantic analysis checks the meaning. We'll go into the next slide. Syntax analysis is the second phase of the compiler that checks where the token follow grammar. Syntax analysis is also known as parsing. It receives the tokens from the lexical analyzer and it verifies whether they satisfy the grammar of the language. The main objective is to verify the grammar and to detect the errors, to build the parser tree and abstract syntax tree, and pass the structure to the next phase, that is semantic analysis. Example: tokens and output will be the parser tree or syntax errors. The grammar in the syntax analysis. The grammar is a set of rules that defines the correct structure of the program in a programming language. It is used by the syntax analyzer or a parser to check whether the input tokens form a valid program. Let's go into the next slide. The components of the grammar. The formal grammar have the some set of components, that is VTPS. V is nothing but it's a variable or non-terminal. T is nothing but terminals. P is the production. S is the start symbol. So non-terminals like T, E, F. Terminals like plus, ID, star, and braces, common braces. Production is tends to like E tends to E plus T. Start symbol, starting point. Usually starting point will be E. This is the production of the grammar. And this is the expression. Always the top priority is given to the star, then plus, then so on. Parser tree. The parser tree is nothing but a hierarchical representation of how a compiler derives the program using the grammar rules. You can see the example. This is the hierarchical representation. It also contains the grammar rules, production rules, and symbols, etc. Abstract syntax tree. Abstract syntax tree is nothing but it is a simplified version of a parser tree. It removes the unnecessary grammar, symbols, and returns only the essential structure of a program. For example, the expression you can see A plus B is represented in the parser tree with a grammar symbol, whereas AST contains only the plus operator and its operand, because AST is similar and simpler, which is much used in the modern compiler for semantic analysis, optimization, and code generation. Let's go to the next slide. Parsing techniques. There are mainly two parsing techniques. The first one is top-down parsing and second one is bottom-up parsing. In the first top-down parsing, which starts from start symbol and construct the parser tree from root to the leaves. It includes a recursive descent parser, predictive parser like LL1, LL, and second parser is the bottom-up parsing, which starts from the input string and reduces it step by step until it reaches the start symbol. Example, shift reduce parser, LR, SLR, LA, LR. Top down parser is simple. Bottom up parsing is more powerful. Let's go into the next slide. Semantic analysis. Semantic analysis is the third phase of the compiler that verifies the program meaning. It ensures the program is logically correct. Even if the program follows the grammar rules, it may still contain the semantic errors. The semantic analyzer performs type checking, scope checking, variable declaration checking, and even function parameter checking, annotate AST. The input will be always parser tree. The output will be annotated AST or semantic error. We'll go into the next slide. Table and type checking. Symbol table is nothing but it's a data structure maintained by the compiler. It stores the information about identifier, function. It is used in the program. This includes variable name, data type, function details, scope, memory location. Another important task is type checking. For example, int x equals 10. It is correct because integer variable stored in the integer type. Incorrect will be like int x equals hello. Hello is the string value which cannot be stored in the integer variable. This is mismatch, type mismatch, because it is not integer value. Syntax versus semantic errors. Syntax errors and semantic errors. The grammar mistakes, it is a syntax error. Meaning mistake, it is a semantic error. It is detected by the parser, it is detected by the semantic analyzer. Missing semicolon, syntax error. Type mistake mismatch, semantic error. Missing brackets, syntax error. Undeclared variable, it is nothing but semantic error. Incorrect statement structure, syntax error. Invalid operation, semantic error. This is the example. We can see the example. If x is greater than 5, we don't have closing common bracket, so it is a syntax error. Semantic, int x equals hello. X is an integer variable. We are trying to assign the string value. Again, it is a semantic error. I hope you guys got it. We'll go to the next slide. The application and advantages. Syntax analysis detects the grammar error and it builds the parser tree, abstract syntax tree. Whereas semantic analysis ensures the logical correctness, prevents the invalid operation, and supports the optimization. The application, modern compilers such as GCC, Java C, and Microsoft Visual C++ uses these phases to compile the program efficiently. We'll go to the next slide. Summary. The syntax analysis, a second phase of the compiler which checks the grammar rules, generate the parser tree, and also detects the syntax error. Whereas semantic analysis, third phase of the compiler, checks the meaning of the program, performs the type checking and scope checking, generate an annotated syntax tree for code generation. Thank you. If you face any doubts, please post your doubts in the comment box so that I can respond.